All right, thank you. So Bill talked about sediment export. I'm going to talk about sediment inputs to the channel network. And there are three processes that I'm going to talk about here, but I want to explain why we looked at these, and I'm going to give you some caveats about them. Part of this was if you saw changes in the amphibians, or if we had seen big changes in suspended sediment export, we might want to know where those changes originated from. Where did the sediment come from? So we looked at a couple obvious sources of potential sediment. Sediment from roads, lots of literature to say that roads have traditionally delivered fine sediment to channels. Windthrow. Windthrow is a big, obvious disturbance event. You heard Dave talk about it. Sediment is displaced, and there have been theories that that sediment could be a big source to the channel. And then bank erosion. You already heard me talk about discharge going up, a 30-day event going up by 50%. Does that translate into increased bank erosion in our treatment sites? So I'm going to cut to the chase, just so I don't leave you hanging here. There were no big changes in any of these sediment metrics. Bill already talked about we didn't see a change in export. And I'm going to throw out some caveats here and say we were looking for big changes, but that isn't to minimize the effort that went into this. A lot of effort, field work went into this, and yeah. So road sediment. Sediment is really a hard thing to measure in general. Road sediment is problematic in measurement. It takes a lot of time. So we modeled road sediment erosion using the Washington State Road Surface Erosion Model, WARSEM, to predict what change in road sediment inputs we would see as a result of the harvest activities. And you saw this graph earlier. And what I want to point out on this graph is here are our blocks. Different blocks here. Some of the blocks don't have all the treatments. Even our Olympic block, which was our complete block, doesn't have the forest practice treatment, and that is because there were no roads that had a connection to the stream channel as defined in WARSEM. So they are not predicted to deliver sediment. The other thing I want you to see is that for the most part, these two sets of graphs, so the yellow is the 2008 year. That was the year when most of the harvest occurred. Some of it occurred in 2009. But in general, you see that the heights of these bars are all pretty similar across time. Sometimes it goes up a little bit. Sometimes it goes down a little bit more. In this case, it was because road traffic levels decreased in the post-treatment period. The only one of these, and you see that the heights of the bars are highly variable. Some basins are predicted to deliver more fine sediment to the channel regardless of the treatment. They did it in the pre and in the post. A lot more sediment in this basin than we see in this basin, for example. The only basin where we see a big change is the 100% Willapa 3 basin. We see it in the 2008 year, and that's where we built a new road, or they built a new road. So in conclusion, in the absence of new road construction, we wouldn't expect, or big changes in road traffic levels, or big changes in the road condition, you wouldn't expect there to be a treatment effect in terms of the change in the amount of sediment coming from the road network to the stream, and that's what we saw here. So it's consistent with our expectations. Windthrow. So again, it's an obvious disturbance event. You heard that we had a lot of windthrow in the pre-treatment years. So this was work that Dave did. It was part of his fallen tree surveys. He was out there before harvest and then 2 years after the harvest. And looked at whether a root pit was formed and whether there was visual evidence of sediment delivery to the channel. So this is the data. So on the left, we have the Olympic block. On the right, we have the Willapa 1 block. I'm only showing these two blocks because there are two complete blocks, and they're the ones where we had sediment export data to sort of tie back to this. Again, we didn't see a change in the suspended sediment export. What you see in these graphs are, so the top panel is pre-treatment, and what we see is that in the Willapa 1 block, we had a lot of windthrow, as Dave already mentioned, and we had some windthrow that actually delivered sediment to the channels. In general, we see that the blue is the width delivery. It's much less than the total windthrow. And I actually gave a talk here, I think in 2008, maybe, in which I showed that sediment delivery from windthrow decreases exponentially as you move away from the channel. The tree has to fall really close to the channel in order to deliver sediment. In our western forests, where you don't get a lot of overland flow, we have an equipment limitation zone, so we have intact vegetation really close to the channel, and you just don't get much overland sediment transport. It just doesn't go very far. So the net result here, and the bottom panel is post-treatment, the net result is that most of the trees fall on the outside of the buffers where they've been cut. They fall less likely in the center of the buffer, and most trees don't deliver. So we didn't see any treatment effect in terms of windthrow sediment delivery. And that was, the one exception to this was pips. So pips have those round buffers up at the top, and they did deliver a little bit more sediment from windthrow in the treatments, and it was the forest practice treatment where we saw a lot of windthrow around those pips. Obviously, the clear-cut treatment doesn't have any trees around pips, but it wasn't significant. It wasn't that big amount of sediment. The final thing I'm going to talk about is bank erosion. I'm sorry I don't have a picture to go with this. So we looked for visual evidence of bank erosion. People were out walking the channels looking for freshly eroded banks. And this was a single post-treatment survey. So it's not one of our before-after control impact. This is just an after survey looking for area of fresh erosion and the length of eroded bank, just to see if in those treatment basins, do we see a lot more fresh erosion of the banks. Normally I eschew putting up tables like this. I don't like tables, I prefer graphs. The reason I'm putting this one up here is because I want you to see that there are a lot of zeros in this data set. And there are also some big values. So if we look at the biggest value here, so this is our treatment reference. This is the number of erosion sites we found, the area of those erosions, the length of channel affected, proportion of the stream network. We look at the biggest value here in terms of erosion. It's here in our Willapa reference. The second biggest is on our Willapa 1 reference. Actually, sorry, here it goes. Willapa 2 reference. The references actually had the most bank erosion in the post-treatment period, and you have a lot of zeros in the data set. And it isn't surprising before doing any statistics to just expect that with data like that, you're not going to see any treatment effect. There is no treatment effect in terms of bank erosion. So the results are no change in the set of inputs from roads, windthrow, or bank erosion in the first 2 years following harvest. And this is where I throw in my biggest caveat with sediment. The biggest impact of forest practices with regards to sediment is landslides, okay? We don't look at landslides in this study. We didn't want landslides. We didn't see any landslides, luckily. Landslides do occur following harvest at accelerated rates. We have other studies to show that, and that sediment is potential impact, but it's outside the scope of this study.